Alright guys, going to do another video for chapter 2 here, except these relate to how we evaluate the value of a function. So the big thing here that some of you guys are getting goofed up with is function notation. So this whole like f of x. F of x is just a fancy way of saying the output value. So I could write y equals negative 9x minus 3. I could write a sub n equals negative 9x minus 3. I could write f of x, I could say f of n, f of p, f of purple. It doesn't matter what this is. It's just a placeholder for what I'm going to plug into the function, what my input is going to be. So regardless of what letter's there, all that tells me is it matches up with the variable in the function. So all that tells me is this is the output value of the function when I have a given input value. Here my input value is going to be represented by x. So f of negative 5 is just saying everywhere you see an x, replace it with a negative 5. So f of negative 5 is really negative 9 times negative 5, then minus 3. So negative 9 times negative 5, negative times a negative makes a positive. So that gives me 45 minus 3, which gives me a value of 42. So I can then say f of negative 5 is 42, and that is my function evaluated and solved. Now the next question is a little bit more complicated because it changes notation. This is nothing to concern you. It doesn't matter whether they use x or whether they use n. It's just a placeholder value for whatever the input is going to be. So even though this initially says if f of x is negative 5x plus 11, and then it says f of n, I can really just think of that as now f of n is negative 5 times whatever my input is plus 11. All that matters is that whatever's in my function notation, that matches what my input in the function is. So now it says if f of n equals 21, well, so f of n equals 21. So I now need to figure out what's the value of n. This is just a function that needs the n isolated. So to get this n by itself, I got to get rid of everything else. Whenever we start the solution process, we always start by getting rid of any constant values first. So I get rid of this constant value 11, and I take it away from both sides. So then I get a negative 5n, do not forget that negative, equals just 10. Then to get rid of that negative 5, it's multiplied by my n, so I have to divide. So I divide by negative 5 on both sides. And I'm going to get a solved n value of negative 2. Now I can check this by coming up and saying, well, what happens if I plug negative 2 into my function? Well, I would have negative 5 times negative 2 plus 11, which then negative 5 times negative 2 gives me a positive 10 plus 11 equals 21. This does agree with what we started with, so we know that what we've done is correct. So that is how we evaluate a function, both for when I have been given the input value and when I've been given the output value and have to determine the input. So whether I know the input or I know the output, I can always plug in and solve for the other missing value. Please let me know if you have any other questions, comments, or concerns from Chapter 2. Right now, this is the end of the videos that I've been requested to make. So I'm going to move on with some other work, but please let me know if you have any issues, and I will try to get things posted as soon as possible. Keep working hard.